So, telling stories about code is my talk title today. It is snakily not about documentation, although it is going to be indirectly about documentation. So my name is Anna Nelson. Here's my Twitter. And I want to talk today about what I'm going to call the story crisis. And this is an idea that's come up a lot of different ways in a lot of different contexts. One of the story crises is that, documentation is a very important shop front. A lot of projects don't have it. And if you can't tell the story of your project in a compelling way, people might use another project, or they might not even be able to do anything productive because they just don't know what a great story you have. So the story crisis is a thing that affects us in a lot of different ways. And the basic idea is that there's so many stories out there. They're all competing for our attention. And a lot of times the stories that people believe, maybe they're not even true, but they might not be the stories that we think people should believe. And this can be a problem in politics when people might want to believe a convenient truth instead of an inconvenient one. Or it might be a problem in marketing when someone isn't going to, someone might be spreading FUD about your methodology or your product. I'm going to talk about an example of the story crisis from science, because I think it's really interesting. And this is a story crisis around cancer research. And a lot of types of scientific research are in a crisis of reproducibility. So there have been a couple of really high-profile researchers have come out and said, hey, so all these papers we all have in these prestigious journals that tell us about basic cancer research. Yeah, I can't reproduce what they said was the truth. And research papers are documentation of scientific research, absolutely. We are talking about documentation. It's all related, it's all the same thing. So here's an example. There's just been a very important initiative which is providing $1.3 million in funding to redo 50 really high-profile research papers. So it's great that we're doing reproducibility. There's going to be a lot of a shake-up of, oops, well, we thought this was true because the paper said so, but we couldn't actually reproduce it. So this is a story crisis. People are believing that things that are effective cancer treatments, things that aren't effective cancer treatments actually are. They're spending money. People are potentially dying. And as well, there's been a lot of research lately about bias in pharmaceutical research. So there's been some really interesting meta-analyses that say whoever pays for the study gets the results that they want in a lot of cases. Obviously, this is concerning because we want some sort of objective truth. We don't want to be spending money on ineffective treatments, and we want to have good science being developed. Some of you might remember there was a really famous case last year. There was a very highly cited working paper in economics which said that if debt is greater than 90% of GDP, then we're going to have a huge crisis in economic growth. This paper was widely used to justify a lot of austerity measures in a lot of different countries. There was just one problem, which is actually that result didn't hold. And a lot of people were saying, we don't get that result. This actually was not in a published journal. This was just a working paper, but everyone was taking it as though it was a peer-reviewed fact. So they couldn't actually reproduce the results. Someone asked for the data. I think a student asked for the data. Turns out there was a mistake, or some people say mistake, in the Excel spreadsheet, and two of the countries that actually falsified the hypothesis were accidentally excluded from the range. So we have very serious consequences potentially when these journal articles aren't actually telling us the right answer. So when I wrote Dexi, Dexi is an open source tool for doing a lot of types of document automation, one of which is software documentation. I'm more than happy to talk with everyone about that anytime this afternoon. But actually, the reason I got into Dexi was an interest in computational reproducibility, which means it's a type of reproducibility that says, okay, you have a result in this paper of 4.7. I would like to be able to reproduce your result of 4.7 so that I can really understand how you got there. And then maybe we can talk about whether your methodology was appropriate. We can have a real good discussion about the story and the science. But first of all, I need to know that your math is right. And I also need to understand exactly what methodology you used to get from your data to the actual thing you're claiming in your paper. So Dexi is a tool for that, and what Dexi lets you do is it lets you link the words in a story to the code and data behind it. And again, it's the same idea if you've got to do software documentation, you're going to make a statement about what your software does, and that should be linked back to the actual code that implements it, because that way you're proving, hey, I said you can do this with the software, here's a little curl script that interacts with the API, and here's the output. So yes, you can see that I'm telling you the truth because I have a working example that's an automated part of my writing process. So Dexi is about automating all the things. It's an open source tool. For a scientific research paper, you can do something like, say, the average value was, and instead of hard coding 4.75 and not remembering how you got that, you can say the average value was average value, which is a variable that you've populated with the correct value. Okay, so this was my initial attempt to solve the story crisis, or at least solve one aspect of the story crisis, which is just to make sure that, all right, let's start with the basics. Is our math right in the paper? Because as we saw from the Excel example, sometimes that doesn't happen, and that leads to serious consequences. So this is really helpful. This is fun. I got to shave an awful lot of yaks, had a great time. But there's a problem, which is computational reproducibility is important, but it doesn't solve a lot of the issues we're dealing with. And when they actually looked at those biased pharmaceutical research papers and asked, okay, how did this bias come about, they found that they weren't fiddling the numbers. So these research groups were getting answers that happened to fit the funders more often than they should, but they weren't doing it by fiddling the numbers, because that's really obvious, and it's a lot of scientists aren't really going to want to do that, but somehow they were getting the answers they wanted. And when they actually studied that, they realized what they're doing is they're learning how to ask the right questions. So they're learning how to ask a question that leads to the outcome they want. So computational reproducibility is not going to help us deal with people asking questions that are sneaky. So for example, you might conduct a trial of your drug against something that you know is going to be less, not as effective, so you're going to look more effective. Actually, what you should be doing is comparing across all the things at appropriate doses and doing all the right things. But if you have the power of framing the story completely, then you're going to be able to do this. You're going to be able to really, really sneakily get your point to seem like the only obvious point. So why is it possible that we can hear a story and be taken in and tricked by the story? And I'm going to talk a lot about evolution. We already heard a lot about fruit flies, and we've heard a lot about iteration, so this is going to be more along that theme that we've all organically risen at. So humans have a lot of very powerful heuristics that throughout our evolutionary history have allowed us to make really quick decisions when we needed to make really, really quick decisions about what to do when there's a lion chasing you or you're trying to get that, kill that animal for dinner. So we have a lot of heuristics, and we have a lot of intuition based on that heuristic. So we have a gut feeling and a common sense feeling for when something is right or wrong. The problem is, our heuristics are great at making quick decisions in a lot of circumstances. They aren't great at analyzing huge data sets and coming up with a really precise answer when you have a lot of time to do the analysis. So our heuristics are not tuned for this sort of problem. They're not tuned for science. And actually, I hadn't thought about this before, but someone pointed out that science is really unintuitive, and that's why it's so hard for us to get it right. We've got to design all these experimental protocols because our intuition a lot of times is wrong about the shape of the Earth and whether bigger things fall faster. So we have to do science, train ourselves to step back from our heuristics and try to retrain our intuition. So because of this, if someone tells a story that can appeal to our intuition, even if it's wrong, we're going to say like, oh yeah, that seems right to me, and we're going to let that go. So that's how stories can lie, but why are stories so powerful? And I've heard, there's a lot of people telling us, look, it's really important to tell a story. It's really important to capture people's imagination. Don't just give people a boring analysis, but give them a story, give them a sense of intuition. And it is really good advice. It is really important to tell stories. But why? What is it about stories that is so important that we are just, so taken in by them and so compelled by them? So there's a really interesting book on this exact topic called On the Origin of Stories, and this takes an evolutionary approach to stories and to art. So this guy is saying that art and fiction are really things that have evolved as they're products of our evolution. And this is a really nice quote that I really like, and I'm just including this in here because a lot of us are programmers and we all understand that, yeah, computers can do more when the operating system lets you do more. So, our operating system is very much designed for flexibility, and fiction is a really, really important part of how we learn. So, a work of art is a playground for the mind. We're drawn to art because it helps us develop our minds, it helps us learn. And learning is a way for animals to evolve faster than genetic evolution would otherwise let them. So bacteria and things like fruit flies and things with a really short lifespan, they can evolve really, really quickly. A bacteria can have a lot of generations in as short as a day. And so those bacteria can alter their genetic code to respond to shifts in the environment. We live a really long time, and it takes us a really long time to reproduce. And we need more flexibility, and a lot of animals need a lot more flexibility than they're capable of getting from their genes. Because if we had to wait for, we'd be dead if we had to wait for our genes to evolve to the point where we could change the way we react to the environment. So learning is a skill that a lot of organisms have. It allows you to change your behavior more quickly than genetics will. And humans and some other primates have culture, which allows us to capture learning and transmit it over a lot of generations. So play is an adaptation of a lot of animals to encourage us and to make us compelled to learn. So here's a couple of very cute lion cubs, and these lion cubs are being really, really irrational because they're running around, they're wasting a whole bunch of energy, and they're not paying attention. I mean, some, wildebeest could come and just, step on them anytime. So why are these animals compelled to go do this, ridiculous activity when, their parents are much more sensible? Their parents are like, okay, it's hot, we're not chasing any food right now, we need to conserve energy because, we're all barely on the edge of survival here. So why are the cubs doing this? The cubs are doing this because they need to learn these life skills. And the way we're set up to learn life skills, and if you've got a dog at home, you're going to know how much they want to play, and it's because they're learning how to do real practical things in the world. And so they're going to do an exaggerated and stylized and very fun and enjoyable form of play with each other. They're going to learn how to fight and chase and stalk and do all those really important things. And so here's a monk, and in a sense, this monk, looks very serious, and presumably he's not reading a work of fiction, but you never know. So this is human play, and humans, we don't sleep all day. I mean, maybe a few people do, but we don't sleep all day, even if we have the option to. We get bored, and boredom is another evolutionary mechanism that says, hey, you're bored, go out and get some stimulation and train that brain of yours, because this is why we're here. We have this power to adapt and to learn and to create all these new adaptations that we can invent, and so we're compelled to play. We watch TV, which is ingesting a form of art, maybe not high art, but it's a form of art, and if you look at what's there, it's designed to engage our minds in a way that's very appealing to us. So what is it that fiction in particular, stories in particular, is teaching us? There's a lot of different skills, but a really, really important one that humans are very, very good at is theory of mind. And if you've read any child psychology, this is a really important thing that people are like, oh, when does the child develop theory of mind? And theory of mind says we think about what we know about the world, but we also make assessments of what other people know about the world. Like, I'm going to predict your behavior not based on what I know, but based on what I think you know. There's a lot of different levels of that. I think humans go out to like the 5th level. It's really, really important. We are social creatures, and all we do is navigate our social environment. That's our primary task in life, is to figure out how other people work, what other people are thinking, what other people know, and how we can survive and thrive in that environment. So art and fiction in particular, and if you look at television and movies, what they're doing is they're helping you simulate real-life situations and helping you improve your understanding of theory of mind. And I like the fact that this is really nicely tied up. So that's the evolutionary perspective. This is advice to story writers from a great book called Anatomy of a Story. And here's what he says. He said, good storytelling lets the audience relive events in the present so they can understand the forces, choices, and emotions that led the character to do what he did. So here's a script writer saying, hey, you gotta basically simulate theory of mind for your audience. So we have a really nice thing here of the evolution and the script writing advice coming together. Okay, so we've seen that there's a story crisis. We've seen why stories are so powerful and so compelling. What can we actually do with this? So how do we solve the story crisis? How do we get our story out there? Or how do we get, I'd like to say, how do we get the right story, the true story out there? And we should, scientists and technical people, we should learn to tell better stories. Yes, that's always been good advice. Learn how to communicate, learn how to tell good stories, learn how to capture your audience and entertain them and interest them. We do need to work on our own biases. So our cognitive biases, we hear a lot about cognitive biases, we hear a lot about confirmation bias and groupthink, and we tend to do all these things. Those are also things that have evolved. There are heuristics, they're imperfect. So we do confirmation bias for a reason. It's actually a lot of times an evolutionarily adaptive strategy, but it also means, it's also imperfect, it also means we're gonna end up believing things that we shouldn't believe because we just wanna believe them. So yes, we should work on our own biases. We should make sure we're not telling stories that aren't true because we want to tell them. Yes, we should use technology for computational reproducibility. But I think all these things are really, really important, but I think we really need to, as a culture, try to figure out a way to change our cultural intuition around story. And now this is me just making stuff up. And I'm saying, okay, our cultural intuition about stories, this is something we can potentially create differently in the future that might be very, very powerful. So here's our current concept of a frame is like, okay, I'm going to tell you a story. I get to choose all the parameters. I get to choose how I set this up. I get to choose all these things, and I'm going to try to convince you of my viewpoint. So let's try to go from that perspective where there's a lot of power, but it's sort of a coercive power. Let's go from that type of framing to this type of framing. So let's go to window framing instead of picture framing. And window framing says, there's a real truth out there. There's a real world we can observe. But there's a lot of different windows from which we can look at that. We can look at that world. And each of those windows is going to have a slightly different perspective. Each of those windows is going to be a story that will appeal to our intuition and allow us to understand some aspect of what's going on in the world. But it's not a case of claiming power and trying to control the conversation. It's a case of saying, hey, I've got a great way to explain my intuition about this part of this behavior. Maybe you've got a great way of explaining your intuition of a different aspect of it. We can critique each other's work. We can figure out what's the best, most helpful explanation for a given purpose. But we can also say, hey, we're all just looking at the same world. And picture framing tends to lead to this false dichotomy of, hey, there's two sides to every story, which is a really confrontational, and it's an approach that sort of denies that, no, there is an objective reality. There is measurable things that we can actually measure, actually compare, and actually assess. And that's what we're trying to do with our data and code, and a lot of times is measure the real world, measure what's happening on our websites, measure what's happening in a scientific sense. So it's not two sides to every story. There's a lot of different perspectives in every situation, but there is a physical reality. So there is a network of data and code around everything we're interested in. So that could be scientific observations, it could be your unit tests, it could be a lot of different things. But there are physical or quasi-physical things that are representing the world. And we have the power to take a lot of different story perspectives on that world. So we can see them in a lot of different ways. You might have one view that's appropriate for managers, and another view that's appropriate for developers, and another view that's appropriate for customers. You're all looking at the same reality. You're expressing it intuitively for a lot of different audiences in a lot of different ways. But we have transparency towards the actual physical thing. We can look at people's work. And now with technology, we can use these computationally reproducible techniques to actually see the relationship from our window to the underlying world. So we have a lot of new possibilities for openness. Open source has really, really inspired the open science movement, which is doing some really, really interesting things now. We're getting to the point where you can publish a research paper, but you can have all the data and all the source code on GitHub. You can computationally build that so someone can reproduce the environment, and then another person can clone that repository and write another paper that reinterprets that data in a different way. So we're at this really interesting point where we can start to build up a lot of perspectives. We can start to more usefully critique each other's work. So let's get to the point where we have a lot of different windows. We can start to look at people's windows and say, okay, your window is frosted and your window is pointing the wrong direction, but these three windows are all just really interesting, different, intuitive perspectives on the real world. And that is my talk. My name is Anna. Dexi is my software, which is useful for software documentation as well as scientific research journals. And hopefully it can start to provide this window using computational reproducibility to look at the real world in new ways. Thank you.
So nothing to do with documentation and reproducibility then. Great. I don't know, questions? Anyone? Comments? I knew that documentation would get you all fired up. Ben?
Which is stronger, the sort of commercial imperative of the drug companies getting the right results, or the evolutionary imperative of kind of just being a better species?
Eventually, it comes home to roost. So the question is, which is more stronger, more important, the commercial importance or the sort of evolutionary truth? I think one of the interesting things has been that the pharmaceutical companies are actually some of the people now funding the reproducibility studies, because they're realizing in the long term, doing this bias and getting this, clinical trial result that favors us, well, in the long term, you're going to get found out, because, the truth is eventually going to emerge and say, oh, actually, you've got things like Vioxx recalls where it's really expensive because eventually people realize, oh, actually, not only is this not effective, but it causes a lot of side effects that you sort of managed to hide in your clinical trial, and now you're going to get sued and all sorts of things. So I think it's in all of our interest in the long term, even if you've got a short-term commercial gain, in the long term that's going to be erased. And I think that's something that people are realizing. And yeah.
Brian?
What are some of the, what are some examples of how you would get somebody away from the whole picture frame line of thinking, which I can see is a really easy trap to fall into, to more of the window frame perspective? I mean, how do you help them make that transition?
Yeah, I think it's going to be a cultural transition of saying, okay, I appreciate your white paper. It makes a really interesting case. Where's the transparent link from your data to the claims you're making, so I can see, are you using 1% of the data set that happens to fit your bill, or is this huge open data set going to, does this make it clear that you actually did choose a representative sample? So I think one thing that's really interesting is that the technology and the culture are going to potentially iterate together. It's so much easier now to share source code and data. So much easier in a lot of ways to be open because we have the tools for it. So I didn't show a slide with the philosophical transactions of the Royal Society. Scientific journals have been around since 1665, and we were really restricted by the print format for a long time in the history of science. You'd write up a journal article, and you might have this much text. Nowadays, you might have a lot longer, but we were really restricted in how much data we could share because we had cost issues regarding print. Now we don't have that issue. So now we can put pretty much as much data as we want up on the internet and distribute it. So we have the technology and the distribution channels to allow openness. That's going to lead to, okay, you don't have an excuse anymore not to be open. So yeah, why do you publish you're publishing a paper, which is an anachronistic term in itself. You're publishing a paper, a white paper or a research paper. Well, why aren't you publishing everything? And why aren't you showing us your automated workflow, and why aren't you doing it? So I think it's going to be people demanding, hey, let's see the data, let's see the code, let's see the whole workflow, combined with the technology making that possible. So I think the culture has to evolve. I think the technology is going to be a way to sweeten that deal.
Now they're coming in thick and fast, Chris.
So I really like the idea of this collaborative window framing versus the antagonistic picture framing. Is there a canonical example of this resulting in a much better decision, or who's the closest to doing this right? Because I like the idea, but I don't know where I point to say that's how they should be doing it.
Yeah, and I think the examples are going to come from people publishing general purpose data sets. So previously a scientist would publish a paper and then hoard their data. And that still happens to a large extent, but now people are saying, you know what? I published my paper, and I might get three more papers out of my data set if I hoard it to myself. If I just put it out there and let a bunch of other researchers use the data, and I provide them with sufficient metadata for them to actually be able to do that, well, maybe there'll be 20 papers that are going to cite my paper, and then maybe that'll lead to a bunch more. So I don't have a particular example. I think openly publishing data sets is going to be an interesting place to look.
Just make a comment on that. I mean, the counter side to that, I've kind of read a lot about is that, researchers put a huge amount of effort into creating that data set, and, many of them want to mine that with a series of papers rather than just having essentially a one-off paper and then other people run with it.
Yeah. Yeah, it's tricky because people do want to, they do want to get the most they can out of that data set. A downside of that is they might overmine the data set. They might reach false conclusions because they've, done that. And then, really, there's so many ways that statistical anomalies lead to, if there's a 5% chance that a result will show up randomly, if 20 people write a paper, the one of them, by chance, is going to hit a positive result. That's the one that gets published, and the 19 negative results don't get published. That's our tradition in the sciences right now. So when we don't have that openness, there's a lot of ways. One of the reasons we get these unreproducible results is that we've only published that fluke paper and not all the other ones.
Thank you, Hannah Nelson.
Thank you.
Thanks a lot.